Today, we're diving into something that sounds like it's straight out of a blockbuster movie, using artificial intelligence to predict supervolcano eruptions. Yeah, you heard that right. We're talking about massive, earth-shaking volcanoes and super smart computers. It's going to be epic. So, first things first, what even is a supervolcano? Imagine your typical volcano, like the ones you see in Hawaii with lava flowing out. Now, multiply its power by, like, 1,000. Supervolcanoes don't usually have that classic cone shape. Instead, they're often huge sunken areas called calderas, sometimes spanning dozens of miles. When they erupt, they don't just spew some lava. They unleash a cataclysmic explosion that can eject thousands of cubic kilometers of ash and rock into the atmosphere. The last one to go off was Toba, in Indonesia, about 74,000 years ago, and it plunged the planet into a volcanic winter. Pretty intense, right? Thankfully, these events are incredibly rare. We're talking hundreds of thousands of years between eruptions. But the consequences are so massive that scientists are super keen on figuring out when the next one might happen. The most famous supervolcano is probably the one hiding in plain sight at Yellowstone National Park in the United States. Don't panic, it's not expected to erupt anytime soon. But it is one of the most monitored volcanic systems on the planet. So how do scientists keep an eye on these sleeping giants? Traditionally, they use a whole bunch of tools. They have seismometers to detect ground shaking from moving magma. They use GPS to measure tiny changes in the ground level. As magma builds up, it can make the ground swell up like a loaf of bread rising. They also monitor gas emissions and changes in heat flow from the ground. It's like being a doctor for the Earth, constantly checking its vital signs. But here's the challenge. All this data is incredibly complex. You get tons of information streaming in 24/7 from hundreds of sensors. It's like trying to listen to 1,000 different conversations at once and picking out the one that matters. A small earthquake could just be a normal tectonic hiccup, or it could be a sign of magma on the move. A change in gas could be a warning, or it could just be a temporary fluctuation. For a human, sorting through all this noise to find a real signal of an impending eruption is a monumental task. It's trying to find a needle in a massive, ever-changing haystack, and this is where our hero, artificial intelligence, swoops in. Think of AI as a superpowered brain that's exceptionally good at finding patterns. You know how your phone can recognize your face, or how Netflix recommends shows you might like? That's AI at work, finding patterns in data. Scientists are now training AI models to do the same thing with volcanic data. So how does it work? Well, it's a bit like showing a kid a million pictures of cats to teach them what a cat is. Scientists feed the AI vast amounts of historical data. This includes data from past eruptions, even smaller ones, seismic records from decades ago, and even lab experiments where they simulate magma moving through rock. They essentially show the AI what the pre-eruption signals look like. The AI, specifically a type of AI called machine learning, chews through all this data and learns to identify the subtle, hidden patterns that a human might miss. It can analyze the frequency of earthquakes, their depth, their specific waveform, and correlate it with ground deformation and gas data in ways that are just too complex for our brains to handle. It learns to distinguish between normal, background chatter and the something is happening signals. Let's get a bit more specific. One really cool technique involves something called time series analysis. All the data from the sensors, the ground shaking, the swelling, the gas, comes in over time. The AI can look at these long timelines of data and spot anomalies. For example, it might learn that a specific sequence of small, deep earthquakes followed by a slight increase in sulfur dioxide gas, and then a tiny bit of ground uplift in a particular spot, has a high probability of leading to a magmatic event. It's not just looking at one piece of evidence. It's looking at the entire symphony of data and how it changes together. Imagine you're trying to solve a super complex puzzle with 1,000,000 pieces. You could try to do it by yourself, and you might get there eventually. Now imagine you have a friend who has already seen 1,000 similar puzzles being solved and instantly recognizes where each piece goes based on its shape, color, and texture. The AI is that friend. It's not magic. It's just incredibly good at pattern recognition on a scale we can't even comprehend. Researchers at places like the University of Oregon and the U.S. Geological Survey are already doing this. They've run experiments where they gave an AI data from a volcano leading up to a past eruption without telling it when the eruption happened. In many cases, the AI was able to successfully flag the period right before the eruption as anomalous, essentially ringing the alarm bell at the right time. It's like a crystal ball, but based on science and data, not magic. This is a game changer. Why? Because the biggest challenge with supervolcanoes is lead time. If we could get a warning years, or even just months in advance, it would be revolutionary. A super eruption isn't something you can just hide from in your basement. It would have global consequences, affecting climate, agriculture, and travel worldwide. An early warning from an AI could give humanity time to prepare. We could stockpile resources, plan for agricultural disruptions, and figure out how to manage the atmospheric effects. It moves us from a reactive position to a proactive one. Now, it's really important to understand that AI isn't replacing human scientists. It's a tool, an incredibly powerful one, but still a tool. The volcanologists are still the experts. They are the ones who interpret the AI's findings, check its work, and make the final call. The AI might say, "Hey, I'm seeing a pattern here that's 95% similar to patterns that came before past eruptions." But it's the human expert who looks at all the evidence and decides whether it's time to raise the official alert level. It's a partnership, a human-machine team working together to keep us safe. Furthermore, the AI is only as good as the data it's trained on. That's why continuing to monitor volcanoes and collect high-quality data is so crucial. The more data we feed the AI, the smarter and more accurate it becomes. We're constantly improving the sensors, expanding the monitoring networks, and refining the lab experiments that create the training data. Every piece of new information makes our AI-powered watchdog a little bit better. So, what's the future look like? We're heading towards a world with integrated AI-driven global monitoring systems. Imagine a network where data from Yellowstone, Campi Flegrei in Italy, and other volcanic hotspots are all being analyzed in real time by a sophisticated AI. This system could provide continuous risk assessments, giving us a constantly updated picture of the planet's volcanic health. This isn't just about supervolcanoes either. This same technology can be applied to predicting regular volcanic eruptions, earthquakes, and even other natural disasters like landslides. By harnessing the power of AI to understand the complex language of our planet, we're getting better and better at anticipating its movements. So, next time you hear about AI, don't just think about chatbots or self-driving cars. Think about the silent guardians sifting through mountains of data, listening to the heartbeat of our planet, and working to give us a heads up before the Earth decides to really shake things up. It is an incredible fusion of geology and computer science that could one day save millions of lives. Thanks so much for hanging out and geeking out with me today. If you found this as fascinating as I do, make sure to hit that like button and definitely subscribe and turn on notifications so you don't miss our next deep dive. Got any questions or ideas for another topic? Drop them in the comments below. Stay curious, and I'll see you in the next video.